Hello students, welcome back to Organic Chemverse. In this video, I'm going to teach you a very important topic, that is aldol condensation, using the given example. The given reactant molecule is a trioxane molecule. It's better to know the name of the molecule. This is a cyclic ether where the oxygens are at the alternative positions. So it's called as 1, 3, 5 trioxane also. But we have substituents. So we have two phenyl substituents and we have two methyl substituents. So when it is treated with an acid in water, it's going to form mixture of products. So probably it's undergoing hydrolysis and forming products. These products are reacting with each other in dilute NaOH upon heating condition, forming only one product called P. With the help of the molecular formula, you can predict what is P, because whenever there is dilute NaOH in heating condition means it's probably an aldol condensation. So using this much information, you have to choose the correct statement or statements from the given options. Now is the time to pause the video and solve this question on your own. Now it's time to verify your answer by solving the question. When this trioxane is undergoing hydrolysis, what will be the mixture of products? You don't have to write the full mechanism of the reaction. Just remember, whenever you have an ether and it undergo hydrolysis, what happens? You're going to get 2 moles of the alcohol. So ROH and ROH, like this. So that means what? This R will also become alcohol. This R will also become alcohol. Since we are having a cyclic ether here, then how to cleave the molecule? All you have to do is, on this carbon, you have to write 2 alcohol. Similarly, here also 2 alcohol. Here also 2 alcohol. So when you are breaking for this carbon, you have to break here. And when you are doing for this carbon, you have to break here and here. Similarly, for this carbon also here and here. So you are going to get 3 moles of geminal diols because it is a cyclic molecule. You will not get 2 moles like this. Within the molecule, you will get 2 alcohols. So how to write this? So phenyl means what? C6H5, and it is attached to 2 OH groups because it is a cyclic molecule. Similarly for this also. So you can see there is a benzene ring and then we have OH here and OH here and then hydrogen. What about this carbon? This is a carbon attached to OH, OH, methyl and methyl. Now, are these geminal diols stable? No, they cannot be stable because still we have acidic medium, right? So they will undergo dehydration. Why do they undergo dehydration? Because on the carbon, 2 hydroxyl group means the carbon cannot withstand 2 electron negative oxygens like this. That's why it tend to undergo dehydration. So both the molecules are same, right? So both of them will form the same product, that is benzaldehyde. We are going to get 2 moles of it. What about this molecule? This also undergo dehydration. But since we have 2 methyl here, we are going to get ketone. So what is this ketone? It is acetone. So what are the products we are going to get here? 1 mole of acetone, right? And what about the other two products? 2 moles of benzaldehyde. So this is the mixture we have now. And it is undergoing reaction in presence of dilute NaOH. Heating condition means it is undergoing aldol condensation. So how to write this aldol product? Let's see that now. The mixture of products formed are acetone and 2 moles of benzaldehyde. When it is treated with dilute NaOH in acidic medium, due to the presence of these alpha hydrogens, it will undergo condensation with 2 moles of the benzaldehyde. So what is condensation refers to? Removal of water molecule. So from where you are removing water? From here. These 2 hydrogens and this oxygen, and these 2 hydrogen and oxygen. And in condensation, 2 moles of water is eliminated. What will be the product? It's very easy to write the structure. So there is carbon here. You write down that as it is, and it is still attached to one hydrogen. You can write that as well. Between this carbon and this carbon, the bond formation is happening, right? So what you can do, write the double bond. So from here as it is, that is the carbon attached to the hydrogen, and the benzene is as it is, the phenyl group is as it is. Similarly, here also you can write like this. So this is the condensation product you got like this, and it is alpha beta unsaturated. Both the sides we are getting alpha beta unsaturated. Now, what is the name of this molecule? This is also called as dibenzalacetone. Acetone, because it is obtained from acetone, and we have the dibenzal here. So benzal refers to the benzene attached to carbon, and here double bond, right? So that's why dibenzal acetone. Let's choose the correct statements from the given options. Option A, in mixture, one of the products shows positive iodoform test. This is a correct statement. Why so? Because out of two products, the acetone, which is having alpha hydrogens, the methyl hydrogens, when it is treated with iodine in NaOH, it's going to form iodoform. So the CH3 part will convert to iodoform, which is a yellow precipitate. Hence, it's going to give the positive iodoform test, whereas the benzaldehyde doesn't have the alpha hydrogens. Hence, it will give the negative iodoform test. Option B, in mixture, one of the products shows positive tolerance and negative Felling's test. So observe here, one is an aldehyde, the other one is a ketone. So they can be distinguished by the both tolerance as well as Felling's test. Okay, but however, one of them is giving both positive tolerance and negative Felling. Which is that molecule? It is benzaldehyde. Benzaldehyde is an aldehyde, therefore it's going to give the positive tolerance test. Because it is an aromatic aldehyde, it's going to give the negative Felling's test. Therefore, this is also a correct statement. Option C is P on reaction with hydroxyl amine gives an oxime that can have 4 stereoisomers. So what will be the reaction? The reaction will be again a condensation reaction, and it's going to form an oxime like this. How many stereoisomers does this molecule exhibit? You don't have to write all the structures. Just look for the double bonds which can exhibit cis trans isomerism. Look at this hydroxyl amine part. The carbon here is attached to the same groups. That means what? This double bond will not exhibit any geometrical isomerism. That means the syn and anti-isomerism is not possible because it is attached to the same groups. However, here this double bond is attached to two different groups here. So you can call this as AB, and here also AC, because these two are two different groups, right? So that means what? This can exhibit isomerism. Same with this also. So how many double bonds do we have here? We have two double bonds which can exhibit the geometrical isomerism. Use the formula 2 to the power n. That means what? We are going to get 4 as an answer. So this is also a correct statement. Now let's look at the last option. Number of double bonds in P is 10. So let's verify that. So what is P? We know that it's a ketone, alpha beta unsaturated ketone like this. Count the number of double bond. Here 3 plus 3, 6, 7, 8, 9. So we have 9 double bonds, but here it's given as 10. So that means it is a wrong statement. So among the given options, we have 3 correct answers. So what did we do here, students? First, we identify what are the mixture of products, and then we have done aldol condensation. How do you know it has to be aldol? Look at the formula of the compound. So there has to be a carbon-carbon bond formation. If you want, you can also calculate degree of unsaturation for the given molecule, then predict the structure of the product also. That's also quite easy. I think I have made this concept clear to you by solving the question. And if you still have any doubts, you can ask them in the comment section. In my next video, I'm going to solve a question based on the Brecht's rule, which is quite important in organic chemistry. Thank you for watching this video. Until next time.